Welcome to EPG Pathshala, and let us take a journey and take another step in geography discipline and move further in the resource geography and understand another new topic called models in resource geography. I am Dr. Seema Mehra Parihar. I have been teaching resource geography and natural resource management for last 30 years. I am PhD in natural resource management in Bhagirathi Basin and a postdoc from ITC Netherlands on WebGIS and geoinformatics, and is involved in making solutions and finding ways and practices of resource management through a lot of convergent projects. So, let us move and learn about the conceptual topic called models in resource geography. Through this chapter, you will be able to understand the needs of models in geography. You will be able to appreciate the difference between pre-Zimmermann and Zimmermann concept of REMOS, and also understand the limits to growth model, and warning that when we have to change or we have to understand that. The key words of this chapter are culture, neutral stuff, modeling, phantom pile and capitalism. Of course, we know that the things are changing, and the definition of geography and geographical thought and geography methodology have undergone a great transformation in last years. In order to put the subject on a sound footing and to command respect in sister discipline, geographers have increasingly concentrated in the last few decades on the theme of geographic generalization, formulation of models, theories and general laws. This geographic generalization is also known as model building. The term model has been defined differently by different geographers. In the opinion of Skilling, a model is either a theory, a law, a hypothesis or a structured idea. Most important from the geographical point of view, it can also include reasoning about the real world, because this real world is has physical or the cultural landscape. It can be a role, a relation or an equation. In the opinion of Eckhoff, a model is something which has a formal presentation of a theory. There is a set theory and according to mathematics. According to the Petch, any device or mechanism which generate a prediction is a model. Accordingly, modeling like experimentation and observation is simply an activity which enables theories to be tested and examined critically. So, by now, what have I told you? I have told you about different aspects of models and how do we define it. It is something which you conceive before starting on to any project. Most of the geographers of the post-Second World War period have widely conceived models as idealized or simplified representation of reality, geographic landscape and man-nature relationship. Significance of this model are many. One is that geography is a discipline which deals with interpretation of man-nature relationship. The earth, the real document of geographical studies, is however quite complex and cannot be comprehended easily. You need model. The earth's surface has great physical and cultural diversity. It has to be modeled. In geography, we examine location, landforms, climate, soils, natural vegetation, mineral, spatial and so on and so forth. All that is available. Added to this is the cultural landscape. We need to model that. But geography is a dynamic subject as the geographical phenomena change in space and time. The subject matter of geography, that is the complex relationship man-environment, can be examined and studied scientifically by means of hypotheses, models and theories. The basic aim of all models is to simplify a complex situation and the reader make it more amenable. In fact, models are tools which allow theories to be tested. A more restricted view of model is that they are predictive devices. So, what are the different needs of modeling in geography? Do we actually have a need? Of course, we have it, you all will agree. A small space also, all those homogeneous and heterogeneous spaces need modeling if we are wanting to have a situation solved. Geographers are interested in making laws and theories in their disciplines like those in physical, biological and social sciences. You will agree by now. Model is a device for understanding the vast interacting system comprising all humanities and its natural environment on the surface of the earth. This is of course not attainable except in a highly generalized manner. Modeling in geography is therefore done due to the following reasons. Number one, a model-based approach is often the only possible means for arriving at any kind of quantification or formal measurement of observed or unobserved phenomena. Imagine a situation, your world is so large, you see a globe is a model. You can just conceive that there is an equator Nobody can travel equator, forget about the days, it will take days and days and years, but because of the model conception, you know it. Models help in estimations, forecasts, simulations, interpolation and generations of data. Next, the future of growth and density of population, use of land, intensity of cropping, migration pattern of population, industrialization, urbanization, growth of slums, and all those predictability analytical models can be evolved. A model helps in describing, analyzing and simplifying a geographical system like locations, theories of industries, zoning of agriculture, land use, patterns of migration, stages of development and landform can be easily understood and predicted with the help of models. Geographical data are enormous, and today remote sensing is enabling us, is giving us big data. But you have to put it in the modular framework. Let it be a raster model or a vector model, but you need to do it, and everything is becoming more complex and has to be contributed. Modeling is undertaking for structuring, exploring, organizing and analyzing the obtained enormous data through discriminating patterns and correlation. Alternative models can be used as laboratories for surrogate observation of systems of interest which cannot be observed directly, and for experimenting and estimating the effects of and consequences of possible changes in particular component, and so on and so forth. Like, there are so many places which are so far off, you cannot go there, but you need to find solutions. And today we are talking in this world of sustainability. We need predictability. Climate change, climate variability is all happening around us. We need models, not only for sustainability, but for surviving. So there is a definitely need to understand the scenario and every scenario of evolution and end states of system of interest. Further, model help in improving the understanding of causal mechanism relationship between micro and macro properties of a system in the environment. Sixth is that model is providing framework within which theoretical statements can be formally represented and their empirical validity can be tested. Further, modeling helps us in understanding the linguistic economy, and geographers and social scientists who understand this language may be further expanded. Somebody has made it, somebody else is using it. That's what the model helps you to use it. Models help in the building of theories, general and special laws. So before moving ahead, I think so by now you all would be convinced that we need models, and models have some further dreams so that everybody can do and formalize their research. Let us now move ahead and take our journey towards features of model. The main features of model are as under. Number one, the geographical reality of the earth's surface and man-environment relationship are quite complex, you all will agree. Models are the selective pictures of the world or part of it. See, today in case of you all know the Mercator's projection shows the whole world. But we all know that India is the 7th largest, but on Mercator's projection, India looks much smaller. Greenland looked much bigger than what is the actual size. It's because we try to model the world map on one particular piece of flat 2D surface. So in models also we have to create assumptions. So model does not include all the physical and cultural attributes of macro or micro regions. In fact, model is a highly selective attitude to information. Models give more prominence to some features and obscure and distort some others. And that's because of objectives. Third, models contain suggestions for generalization. As stated above, predictions can be made about the real world with the help of the models. Fourth, models are analogies as they are different from the real world. In other words, models are different from realities. I hope you all will agree to it. It's not ditto. It is only visualizing for a particular objective that you are involved in research for, right? So it's not ditto to your reality. Next, model tempt us to formulate hypotheses and help us in generalizing and theory building. Models also show us some features of the real world in a more familiar, simplified, observable, accessible, easily formulated or controllable form. I repeat this. Models definitely make all these factors into simplified observations, accessible, easily formulated or controllable form from which conclusions can be drawn. Models provide a framework wherein information may be defined, collected and arranged. Defined, collected and arranged. Next, models also help in squeezing out the maximum amount of information from the available data. Models help to explain how a particular phenomena comes into existence. Models also help us to compare some phenomena with the more familiar ones. Further, model cause a group of phenomena to be visualized and comprehended which otherwise could not be comprehended because of its magnitude or complexities. Models form stepping stone to the building of the theories and laws. So that means stating all these 13 facts which you all agree with, we need models to do research in a meaningful, expressional way. Let's now move towards one person who I always say is a father of resource geography. Of course, you know the name by now. He is called, starting with Z, yes, Zimmermann. So let's move ahead and understand the Zimmermann's model. Professor Zimmermann's, his definition is the resources does not refer to a thing or a substance, but to a function which a thing or a substance may perform, or to an operation in which it may take part, namely the function or operation of attaining a given end, such as satisfying a want. In other words, the word resource is an abstraction reflecting human appraisal and relating to a function or operation. In a pre-Zimmermann era, only tangible or material substances were considered resources, and different minerals like iron ore, copper, bauxite and so on were only called resources, whereas intangible things like peace, culture, wisdom, policy were not considered as resources. But in the words of Professor Zimmermann, whereas less important invisible and intangible aspects such as health, social harmony, wise policies, knowledge, freedom are ignored even though possible, these latter are more important than your tangible products. Because ultimately, if you remember, in your first class you were told, is that resources are not, they become. Resources cannot be created. It's a free gift of nature. And Zimmermann called it a neutral stuff. Creating, modifying, extending, elaborating, expressing, all these can only be done in case if the role of the man is strengthened. And once we do that, we understand this, we can recall the legendary remarks which are, again in the words of Zimmermann, man's own wisdom is his premier resource, the key resource that unlocks the universe. That means all of you, the one who is watching this lesson or a lecture, you are a resource. Each one of you is important. That's what not only Zimmermann says, but each one of us also have to strengthen ourselves, our competency, and that competency management in the world of this resource is again in a way a model structure that Zimmermann created. Considering resource a static or fixed asset was another misconception in those days. In reality, the potential ability of resource cannot be measured precisely, as always it may increase with improved technological advancement. Technology is a key thing. Of course, Zimmermann has told all of us that resources are dynamic, but at the same time, he gave us a new concept called PP. Please remember this concept. You never know, you may be asked in any interview also, and the concept is called the phantom pile. The functional capacity of coking coal has increased fourfold for smelting iron ore. The yield of a product has doubled. How has this happened? Same piece of a neutral stuff gives you much more output in case if we add technology to it. So that is a concept of phantom pile. On the whole, its functional capacity has increased. The physical loss is overcompensated by the expansion of the functional capacity. So what are we talking about? We are talking about the physical capacity and we are talking about the functional capacity. Physical capacity remains same, but the functional capacity has increased with the intervention of technology, know-how and education. This shrinkage of the weight and volume of the resource on one hand and expansion of functional capacity is known the concept of phantom pile. The concept was given by Zimmermann. Early geographers were totally ignorant about the property of resistance hidden within things or substances. If resourcefulness is considered as positive aspect of resource, resistance is the opposite to that of resource. Like assets and liabilities or profit and loss, resistance is overcome by the development of technology of the society, with the society as a whole achieved through its mode of production. Resistance removal is a major task of the resource developers around the globe. Let us just revisit this concept of resource and resistance. Resource is when you use it. Resistance is when there is a need to resist it. Say for example, if you are getting a water is there, you have too much of water, that is called a resistance, that is called in the name of floods. You have less water, it is called a drought, whereas you have an optimum and you have everything like that, and that is called a resource, and you are using it for different purposes, for taking a bath, cooking your food, creating hydroelectricity, all these are resources of water. So, utility, flood, drought are all happening together. So, you only need to revisit them. And unlike the early age, geographer Zimmermann has analyzed both the aspects of resources, that is its resourcefulness as well as its resistivity. Culture in the Zimmermann model includes derived factors such as machines, tools, means of transportation and communication, warehouse, and further culture also consists of immaterial things such as customs and the social institutions which the people create. I hope you all will agree, if there is a person who is having a different attitude, the same particular physical resource becomes much more conservative, whereas the other person who is forward looking, the same resource gives you much more better result. And these social institutions along with the local custom help us to understand the relations which men might have with the resources found around them. So now let us explain. So now in case of all those things, so what have we understood in the resource model? There is a neutral stuff everywhere, you will agree to that, and then there is a spearhead. Zimmermann has made this spearhead, that this spearhead penetrates deep in the neutral stuff. Let us understand Zimmermann's model once again. You have a neutral stuff all around you, what is readily available by nature. You have a spearhead that Zimmermann has conceived, and you push that spearhead inside the neutral stuff. So now once you spearhead, once you push that inside, it either becomes a resource or it becomes a resistance driven by technology and culture. And that is what is Zimmermann's model of resource, resistance and neutral stuff. There is a total antagonistic relationship between resource and resistance, which we all understand by now, like light and shade. And this is something of course which is very sad it's happening, but it's a reality, it's a pragmatic viewpoint. Inverse relationship is a key issue in the overall scheme of resource creation. Anything or any process that restricts substance becoming resource is called neutral stuff. Fertility of soil is resource, but barrenness is resistance. Rain may be considered resource, but flood is resistance. In the same manner, knowledge is a key resource while ignorance is the worst type of resistance. In this connection, the concept of neutral stuff has been introduced by Professor Zimmermann. Anything or substance, be it tangible or intangible, should be either a resource or neutral stuff. If anything or substance does not contain functionality or utility value, it is termed as neutral stuff. So, a neutral stuff should not necessarily remain neutral forever. You all will agree. What is considered neutral stuff today may transform into resource tomorrow. Man's knowledge, wisdom and technological innovation may transform neutral stuff into precious resource. For example, petroleum was not considered resource until 1859 because man was quite ignorant about its uses, while with the development of science and technology, it is now considered as a mainstay for harnessing energy, and you're all cars and all the vehicles which are traveling only because of that. The process of economic development is directly proportional with the rate of conversion of neutral stuff into a resource. The advancement of modern civilization is synonymous with the transformation of neutral stuff into resource. If we peep through the windows of history, it reveals that despite having enormous amount of minerals, water resources, human resources, wealth, etc., some countries could not develop themselves, while others, without having any one of them, because of the technology, skill, zeal, national pride and simple endeavor, were able to transform their own meager neutral stuff into resources. Japan is one example for this, and in case if you have a look at it, Bihar may have many resources, but Japan is the one is having more resources than that, but Japan is the one so much developed. Yeah, so we need to work towards it and we need to think about it. The functional theory of the resources is the one that we call it. Resources were not defined as means of attaining given ends, that is individual wants and social objectives. So that's something which is so very important. It means that anybody that's happening around us is the one which is dynamic. And the statement of Zimmerman, I like to say it again, is guiding us that it's a functional theory of resources. Resources are not, they become. With increasing knowledge, function of resources may enhance. A primitive man may not be able to harness resource from a substance, but a supra-animal, modern man may be, because of his scientific acumen and a Midas touch, may transform even a simple substance from a precious neutral stuff into a resource. To a man of animal level, resistance plays a very dominant role, where nature poses obstacle for resource creation. But to a modern man, knowledge plays as a key role to convert neutral stuff into a resource, and you all will agree to it. The tropical Africa is well endowed with huge water resources, but due to the backward economy and technological drawbacks, inhabitants of that region cannot convert into energy. On the contrary, and of course we know the Japanese were the ones, they were able to produce huge energy from far less water resource. So that will, scientific knowledge, expertise, greater economic development makes all the difference. Advancement of civilization is a product of expansion of human information base. Information about anything. Today we have it all around us. You go to a Google search and you may find so much of information. You have remote sensing GIS technology where you can find all database in your hand and you all can move ahead and you can, because of that, convert neutral stuff into a resource. This increasing knowledge reduced the resistance of the natural things or substance and converted them into resources. So Wesley Mitchell had also aptly said that incomparably greatest among human resource is knowledge. So what the efforts of man through the functional or operational process, resources dynamically created. Without human effort, resources cannot be created. So without your effort, it cannot be created. You have to create a demand, you have to create a process to convert that neutral stuff into a resource, and that's something with the help of your skill, your knowledge, your know-how, that's important. So resource creation process is highly dynamic in nature. So now, of course, all these things are correct, but this also has some limitations. It fails to appreciate the state mechanism which controls the access to resources. That was not recognized by Zimmerman, but we know that that's a reality. Number two, Zimmerman could not identify the imperialistic war on the people across several vulnerable sections who have been victim of the primitive means of capital accumulation by the imperialistic across the world. We saw it, and so now that means, but we have to clap hands for Zimmerman for giving us the idea of functionality. Let's now talk about the second model. Let us look into a new model, which is a limit to growth model. And this model is very important because ultimately we all have to recognize dynamism in the transferability of the resources exists, but there is a limit to it, and that's what this model says. There is a limit to resource exploitation, and the capitalist need for accumulation is intensifying, and this intensification is leading to some policy making by the countries in order to resolve the growing contradictions. The debate has now started on the side effect of the economic growth. The limits to growth model traces its origin to the Malthusian theory, you remember that, and resources shrinkage. It was J. Forster who in his book World Dynamics, published in 1971, devised this model that investigate the interplay of such highly aggregated variables as the world, population, industrial world production, food supply, population and natural resources still remaining in the world. And he said that, and of course using the system dynamic methodology of the Forster, the authors of the limits growth constructed the following. Number one, an elaborate computer model of the world. They presented a larger and new type of model designed to predict the future development of 5 global interrelated variables. Number one, population. Number two, food production. 3, industrial production. 4th, non-renewable resources. And the 5th was pollution. They constructed that in their database, and the continued growth leads to infinite quantities that just do not fit into a finite world. And this basic idea has been elaborated in a highly complicated model which cannot be easily described in equation form. This is because the many relations between the 5 variables are not rectilinear. The multipliers in question depend on the level of variables. Among the various relationships, there are feedback loops. And these feedback loops are also important. They register the effects of change in one variable, such as food production, or another variable like population growth. For example, population growth is positively related to food production, you will agree. But food production is negatively related to pollution, and pollution in turn is positively related to industrial output. The model also uses past data on such factors as growth rate of population, industrial output and agriculture productions, and the estimates of rates of technological progress. Imagine all these are computerized, and these factors would lead to the use of new resources, raise agricultural productivity, and control pollution. Assumptions of this model are many, but the most important are, the assumption is that the models are based on highly non-linear relations. Population increase, the difference between the birth rate and death rate is influenced by crowding, food intake, pollution, and the material standard of living. A rise in any of these 4 factors tend to drive the birth rate downwards. The death rate decreases with increasing food intake, you agree, and the material standard of living, and increases the increasing pollution and crowding. Next, second is that the material standard of living depends on the level of capital relative to the size of the population and the productivity of the capital. Again, we all agree to it. Non-renewable resources are continually used up by the production processes. The lower the level of non-renewable resources, the more capital must be allocated to obtaining resources, and thus the productivity of the capital for producing finished good is less. Agriculture production totally depends on land and on capital investment in agriculture. Land can be developed or eroded depending on investment decisions. Yields per unit of land can be increased by capital, but with diminishing returns. You remember that model? Yeah, that increasing returns and then further plateau and then the diminishing returns. Pollution is generated by the production processes and gradually absorbed into a harmless form by the environment. High accumulations of pollutions lower the absorbing capacity of the environment. We all know all this. So what is the operation of the model? Let's understand that. A major purpose in constructing the world model has been to determine which, if any, of these behavior nodes will be the most characteristic of the world system as it reaches the limits to growth. We are worried about limits to growth, and that is the reason this model became important. Limits to growth concluded in 1972 if the present growth tends in the world population, industrialization, pollution, food production, resource depletion, and continuing unchanged, the limits to growth on this planet will be reached sometimes within the next 100 years. The most probable result will be a rather sudden and uncontrolled decline in both population and industrial capacity. I hope you are understanding the limits to growth. The limits to growth is the population increasing, there is a limitation, and beyond that a diminishing return, and then you will stop. Is it happening? India becoming first, China becoming second. Is it happening? The limit to growth model projects consequences of continuous growth in world population. The thesis says that the growth in industrial sector is not compatible with the planet's capacity and the resource capacity to carry and sustain the population growth. And so now this is what it is. Let's understand the shortfalls of this and the limits to exponential growth. Food resources and a healthy environment are necessary but not sufficient conditions for growth. Even when resources are abundant, growth may be stopped by social factors. Of course, the society will not be certainly surprised by the crisis point at which the area of the land needed become greater than the available. Symptoms of the crisis will begin to appear long before the crisis point is reached. Food prices will rise so high that some people will starve, war times and all that. Others will be forced to decrease the effective area of land they use and shift to lower quantity diets, and thus caught in the death trap due to malnutrition. And we see farmer suicides happening. We are seeing people moving from one land of another. We are seeing environmental migration. Isn't it sad? There is a direct trade-off between the producing more food and other goods needed by the mankind. The demand for these goods is also increasing as population grows, and therefore the trade-offs becomes continuously more apparent and more difficult to resolve. If the first priority to produce food continue, population growth and the law of increasing cost could rapidly drive the system to the point where all available resources were devoted to produce what? Of course, my basic requirement of food, leaving no further possibility of expansion. The exponential growth of demand for food supply results directly from the positive feedback loop that is now determining the growth of human population. Non-renewable resources, if you look at it, the resources that permit growth of capital stock tend not to be renewable resources, but non-renewable resources. Are there limits to the earth's supply of these non-renewable resources? Even taking into account such economic factors as increasing prices, with decreasing availability, pricing is of course one thing. It would appear at present that the quantity of platinum, gold, zinc and lead are not sufficient to meet the demands. Meadows concluded that at the present rate of expansion, silver, tin and uranium may be in short supply, even at higher prices by the turn of the century. By the year 2050, several more minerals may be exhausted if the current rate of consumption continues. Pollution, of course, Meadows said, would increase. Of course, we do not want pollution around us. And of course, we also recognize the law of thermodynamics where we say that everything is there that's conserved. But with pollution, no, of course not. The pollutants are the ones which are closely related to the growth of industry and advances in technology. Further, it is not known that how much carbon dioxide or thermal pollution can be released without causing irreversible changes in the Earth's climate. Of course, climate change research is happening, but how much radioactivity, lead, mercury or pesticides can be absorbed by plants, fish or human beings before the vital processes are severely interrupted is again a big question mark. And we can of course, but nevertheless it's a great model, it's helping us in making predictions, warning us there is a limit to growth, that itself is a great contribution of the model. And the thesis is that the continued growth leads to infinite quantities that just do not fit into a finite world. This basic thesis can be analyzed as under, number one, the future world population level, food production and industrial production will grow exponentially and will become increasingly unmanageable and then collapse during the 21st century. The collapse follows because the world economy will reach its physical limits in terms of non-renewable resources, agricultural land and the earth's capacity to absorb excessive pollutants which are finite. And the third, even vital minerals such as copper, gold, lead, mercury, natural gas, oil and so on are being exhausted. If in addition industrial production continues to increase, that too will give rise to catastrophic results. If the present growth trends in world population industrialization, pollution levels, food problems and resource depletion continue unchanged, the limits to growth on this planet will be reached within the next 100 years. The most probable result will be rather sudden and uncontrollable decline in both population and industry capacity sometimes before the year 2010. That's what that model said in 1970s. But we see that this is not happening. Since the technological progress cannot expand physical resource infinitely, it would be wise to put limits on our future growth rather than await the doomsday within the coming 50 or 100 years. This catastrophe cannot be averted by controlling the growth rate of output and population, reducing the pollution levels and thus achieving a global equilibrium with zero growth. Of course, we know it's not possible. Thus, the Limits to Growth report developed an interactive simulation model that produced a variety of scenarios which were especially useful for defining what was to be prevented. It stressed that pollution, high population growth rate and as shortage of food and food resources make the future prospect of the world bleak, which will lead to disasters, catastrophic results. And since the resources are finite and are likely to be depleted within 50 or 100 years, people should change their, yes, you and me we are talking about, change your attitude towards the use of resources, their reproduction and pollution levels so as to save the world from collapse. It's so important. So that means take care, just get warned. Of course, not the scale, but get warned. Evaluation, of course, said that this model neglects many things. It, of course, somewhere along the line did not talk about the technology. The size of reserves and non-renewable resources has been increasing due to the rapid technological development. I agree. But again, limits to growth is a reality. and scarcity is something which we all should be actually scared about. We all know that there are so many things which are around us and we have to take care of it. According to Giddens, it is a world of endless change and endless expansion which the limits to growth report overlooks. But endless expansion, do you think it's like that? That's for me and you to decide. But according to H. Khan, whenever certain limits are reached, new technologies are introduced with the passage of time. And these technologies effectively either remove the limit or as time passes, subsequent technology can remove the limit. So we can be optimists, we can be pessimists. That's between us. But nevertheless, we of course have to be warned that there are limits. We should not be very happy that we have enough. Exponential rate is something which is definitely there. And what we need to work towards it. The world population of course has not grown exponentially. It was 6 billion in 2000 as against 7 billion predicted in the model. Highly populated countries like China and India have slowed down their population growth rate by adopting birth control measures. Empirical studies have shown that economic growth accompanied by rising income have lowered the fertility rate. Model assume that the pollution level is of course increasing exponentially but not at that fast pace. But that doesn't mean at all that the limit to growth has not sent us a message. And the message is enough. And as the quote which I started off with of Mahatma Gandhi, we have enough in this world for man's need but not enough for man's greed. And that's something which is there which we need to think of. And this limits to growth report suggests a zero rate of economic growth. But again, we all need to work out that there are so many things which are there. So through this lesson, what we have done today, we have definitely talked in this lesson of three things. We have talked about the models, which are of course so relevant today in case if we want to think of natural resource management. Of course, necessity is the mother of invention. We all need to work towards it. But first of all, we need to have the correct intentions. We need to create correct models. We need to think of our objectives, and objectives should be so honest that we want to take care or we want to manage our resources so that we do not have too many of resistances. But anytime we talk of neutral stuff around us, we should find our technologies, we should find our education, we should force our policy makers, we should force all those decision makers who are around us to make and to see to it that this world, all these models which are created are ultimately to convert neutral stuff into a resource and not a resistance. And also, of course, that's for you and me to decide. And also through this lesson, we learn another thing. And that another thing that we learned in this lesson was the Zimmerman's model. And of course, 3 words of Zimmerman's model. Which were these? Yes. Neutral stuff, resource, and resistance. Yes. And one little definition, resources are not, they become. They're culturally driven. And the second model that we talked about today was, that was of limits to growth, which talked about, which warned us that there are limits. Of course, we have seen there were other people, there were other academicians who said that it's too much of a predictive models. It did not take into account the technology and the dynamism of that technology. But again, for me and for you to decide, we all are seeing around us that the pace at which the population is expanding, we all need to create new and dynamic models which will convert the neutral stuff into a resource, and we all would be able to sustain our living and also will be able to think of sustainability, sustainable development. That is, we all would be able to think of the future generations. Yes, you and me would ultimately decide, create models, and will make this world a happier place, and at least taking care of our own individual spaces. Please do that. Let's join hands for that and create new models. Yes. Thank you very much. I hope you enjoyed this lesson.